velocity vector. We know that what is velocity? Velocity is the rate of change of displacement of a body with respect to time. Okay, so in simple manner we will write velocity is equal to displacement by time. Velocity is equal to displacement by time, and you know that velocity is a vector quantity. Why it is called vector quantity? The reason is displacement is a vector quantity and hence velocity is a vector quantity. When velocity is a vector quantity, let us define a velocity vector how it is in two-dimensional view by taking x and as well as y axis. Okay, so let us take this is y axis and this is x axis where the particle is moving. See here, this velocity is resolved into two components, horizontal component and vertical component. Horizontal component is taken as Vx and the vertical component is taken as Vy. The reason for taking Vx is along x-axis is rate of change of position of a body along x-axis and rate of change of position of a body along y-axis. So rate of change of position of a body along x-axis gives velocity of a body along x-axis, and rate of change of position of a body along y-axis gives s velocity along y-axis. Clear? Okay. Now if I am talking about, as per formula you can write velocity is equal to displacement by time, and here you know that velocity for a duration, it is not possible to say that body is moving always in one direction. Okay, body can change the direction, it can go x-axis and it can turn to y-axis, then it is changing the direction. When the body is changing the direction or magnitude is changing, then we will define average velocity. What we define? Average velocity. So average velocity can be defined as the total displacement to the total time taken by the body. Average velocity is equal to total displacement divided by total time taken, or you can say time interval. So here you can write the displacement as delta r is equal to time interval is delta t. Further I can change r2 is the final position, r1 is the initial position, divided by delta t I can write, and you know delta v average is equal to, can we write this r2 and r1 as in terms of x and y? Is it possible to write? So you can write this as, you know, r1 we have written r1 is equal to x1 I cap plus y1 j cap, and r2 is equal to x2 I cap plus y2 j cap, and we have written delta r is equal to x2 minus x1 I cap plus y2 minus y1 j cap. Okay, this delta r can be expressed in terms of what? Can be expressed in terms of change in position along x-axis, change in position along y-axis. I can write this as, so this delta r can be expressed in terms of this one, x2 minus x1 I cap plus y2 minus y1 j cap divided by time interval. Or else we can write this as change in position along x-axis is delta x I cap plus delta y j cap divided by delta t. Then you can write this in terms of what? You take the individual division. V average is equal to, what we can write? Delta x divided by delta t. This is I cap plus delta y divided by delta t j cap. What does it mean? Rate of change of position along x-axis. Rate of change of position along x-axis gives the velocity of the object along x-axis, Vx I cap, plus rate of change of position along y-axis gives velocity along y-axis. So this is your average velocity of a given body. Okay. or else you write in terms of delta y. I will write in term, because you have taken delta x and delta y, I will write like this: V average is equal to, this is delta Vx I cap plus, because delta is indicating change in the velocity of the body, change of velocity of a body along x axis, and this is delta Vy j cap. So suppose if you want to write the magnitude, then we can take V average is equal to square root of component of I is delta Vx square plus delta Vy square. This is what magnitude of the average velocity. Magnitude of average velocity. And we can also write its direction as, I will write here, tan theta is equal to delta Vy divided by delta Vx. We can represent this as delta Vx, and this is delta change of position along Vy. Okay, so this is your change of velocity, or you can say average velocity. So theta is angle between the average velocity and this direction, velocity of a object or component of velocity along x-axis. This is called component of velocity. So we resolve the velocity into two components. Horizontal component is delta Vx I cap plus, and this y-axis velocity is delta Vy j cap. Okay, this is your average velocity. Got it? Clear? Okay, fine. Then, so this is the formula for finding out the direction. To understand this, we will go for one example.